In the last video, we saw why most students get rejected and how OOP is not optional anymore. Today, we are going to one level deeper. Let's actually see the difference between procedural style and object-oriented style using codes and understand how OOP makes your code cleaner, reusable, and interview ready. What is procedural code? It's basically step-by-step logic but no structure. We just write a logic from top to bottom, no grouping of data or behavior. Yeah, procedural code runs in a straight line, top to bottom. You declare a variables at the top, then write a functions, then call them one by one. It's like a writing a to-do list and following it. Think of it like writing cooking steps on whiteboard. You follow them one after one. But what if you had 20 recipes? That board would become unreadable, right? In procedural code, your data lives separately from the logic that uses it. So if you're storing a student's name and age, that's stored using variables. And the function that displays it is written elsewhere. There's no connection between them. It's like keeping all ingredients in one box and cooking instructions in another. Every time you cook, you need to match both manually. In procedural style, you often repeat yourself. Want to show data of 10 students? You'll copy paste the same display logic 10 times, just with a different variable names. That's inefficient. You'll have variables name like name 1, name 2, age 1, age 2, age 100. The more students you have, the more variables you need to manage. This works fine for a tiny program, but when your code grows to hundred of lines, the system crashes. Changing one piece of logic affects everything. It's like a building a house without a blueprint. You can do it for a hut, not for a five-floor building. If someone else opening your procedural code after 6 months, they'll go like, what is even happening here? There is no structure, there is no grouping, no clarity also. In real life, we think in objects. A student has a name, age, behavior, but in procedural style, you don't group them. That's why it doesn't match how we think. To be fair, procedural style is great when you're learning basics, logics, loops, conditions, but once you go into real world software, this style becomes a big blocker. Let's say you write a function to display a students of data. If you want to reuse it for other types of users like teachers, customers, or admins, you can't. You'll end up writing new functions again and again. All data is open and exposed. Anyone can change accidentally your variables, and that causes bugs. OOP gives us private and public controls to fix this. We'll learn that soon. Let's store two students in procedural style. Yeah. Each student's data is stored in individual variables like name 1, age 1, and name 2, age 2, and so on. If we add a third student, we have to manually write name 3 and age 3. No automation. It's like writing the names of players on different pages instead of using a team sheet. Name and age belong together. They're part of the same person. But here, they're stored in separate variables, separately for each person. Think of storing a customer info name, phone, address. Would you store them in different boxes? Nope. You want one customer container. Even if we made a display function, we still have to manually call it for every student's like display name 1 and age 2 and so on. The problem is when the number of student increases, function calls increases. You repeat again and again, increase the chances of bugs. Procedural code leads to repetition. You copy paste variable names, write the same display calls, just with different values. It's like writing a separate resume for each person instead of using a single template. There's no way to reuse data or logic in smart way. Everything is manual. In OOP, you make a student once, then reuse it 100 times. In procedural, you make it 100 times. Let's say you made a spelling mistake on variable name called name 12. How would you even catch it? With 100 plus variables, even finding a bug becomes a nightmare. Like trying to find one wrong spelling in a messy Excel sheet with 500 rows. We store name and age in variables and display logic in separate functions, but there's no connection between the two. A student has the ability to introduce themselves, but in procedural, the student's data and their behavior are split apart. In real life, a student is one unit name, age, behavior, all packed, but procedural style treats them as a gathered data. Think of a WhatsApp contact. It's stored as one entity, name, number, DP, and etc. Not in separate files. Imagine this code for 100 students. You'd have 200 variables, 100 function calls. Making a change in logic, you'd repeat it 100 times. This code is impossible to scale. That's why it's fine for practice, not for real projects. You can't attach custom behavior like introduce, apply for exam per student because Procedural doesn't support binding data or logic. In Loop, we'll attach these behaviors directly to each student using methods like dot display. That's where magic begins. As small variables get added, we might mismatch name and age, like name 5 with age 4, leading to bugs. Just like mismatching names on ID cards. Very funny, right? Like Chad gets Winky's photo. Yeah. This type of code shows you can write a logic but not structure. And companies care about clean and maintainable, scalable code, not just working output. Here's a basic procedural program where we store and display two students' details using separate variables. We use a function called display to print the name and age. Looks clean for two students, but imagine doing for 100 students. That's where a procedural code starts to breaking apart. We're storing the first student's name, it's Priya. We assume maximum 20 characters using the fixed array. Now we store Priya age in completely separate variable. There's no grouping, just individual place floating around. Same thing again for Ravi. We duplicate the same variables. If there was 100 students, you would write 200 lines of variables declaration. That's insane. Now, we made a small function to display student details. This is the only reusable part in this code. Calling the function for Priya and then again for Ravi. You see what's happening. We're repeating the same logic manually. And it's only two students. Imagine doing this for 50 students. You'll copy paste all variable names and change just the numbers. And if the display logic changes, you have to update every function call. That's bad design. In real world software, you don't want to manually type variables like name 99, age 99. That's where OOP and structure like class comes in. We'll use those makes this scalable in next slides. So yeah, procedural style works when you are learning to code, but once your logic grows, it becomes a messy monster with separate variables, no structure, and tons of repetition. And that's why we need a better way. And that's where OOP steps in. And what is OOP? Instead of keeping a variables and functions separate, we group them together inside a class. That makes each object more self-contained. For example, a student has a name, age, which is data, and a display method, which is behavior. They live inside the same unit. Once you write a class, you can create multiple objects from it without rewriting your logic. That's clean code. Imagine printing 100 ID cards from one template. You don't read all the ID cards each time, right? OOP matches the way we think. A student, a car, a bank account, all of this can be modeled as objects. Each has its own data and behavior. You can give a car 1 and car 2 different speed and models, even though they come from the same blueprint. OOP is used in all big applications. Why? Because it's scalable and maintainable. You won't survive in tech interviews without it. Amazon, Android, banking software all uses classes and objects, and also inheritance and encapsulations. They don't train random variables for 10 million users. And OOPS lets us simulate the real world. An object is not just a value, it's an entity that can do things. For example, think of a dog object. It can bark, eat, and sleep, just like in real life. A class is like a drawing of car. An object is the actual car you drive. So yeah, OOP solves the mess of procedural code. Instead of repeating a variable again and again, we create a template once and reuse it. That template is called a class, and each student is an object. It's how real world apps are built, and it's how you'll crack placement interviews. No repetition, real world thinking, and scalable logic. That's the OOP mindset. We'll discuss student example using OOP in Java. First, we create a class. A class is like a template or blueprint for objects. Just like an architect draws a design once and builds multiple houses from it. We can write a class once and create multiple students. Inside the class, we define variables like name and age. These are called fields or attributes of the student. This way, you no longer need to separate variables like name 1, age 1, and so on. It's all inside one unit. And now we create a method called display inside the class. This method will print the student details. So now each students know how to introduce themselves. For example, if a student introduce yourself, they know what to say. But same thing here. We gave that skill to our object. We created two students, S1 and S2, using a new keyword. This means makes me a new student object based on the class blueprint. New keyword. New keyword is like hitting a print on a blank ID card template. Now you get a real one with actual details. Once we create an object, we set their name and age using s1 dot name equals to Priya and so on. Each object can have its own unique values. Now we just call s1 dot display and s2 dot display. Each object calls its own method and it works. No need to pass name and age. It's already inside. Notice no more name 1, name 2, age 1, age 2, madness. Everything is neat, reusable, and grouped. You can now create 100 students using a for loop or array. The structure won't break. That's the power of OOP. We started by creating a class called student. A class is just a blueprint, like a format we'll use to create real students later. Inside the class, we define two variables: name, which stores the text, and age, which stores the numbers. This belongs to every student we create. Now we add a method called display. This prints the student's name and age. Notice we don't pass anything here because this method already has access to name and age of the student's object it belongs to. That's it. Our class is ready. It defines what a student is, their data and behavior. And now we start the main program. Everything begins from the main method in Java. This is the main method. Java looks here to start the program. Don't worry about that public static void main now. We'll break that down in a future episodes. Yeah, here we created the first student object S1 using the new keyword. This line means, hey Java, give me a new student based on the class we defined. Now we fill in the details. Priya is the name and 21 is the age of the first student. Same thing again. We create a second student S2 and give Ravi his name and age. Now the magic. We call the display method on both objects. Each student introduce themselves using the method inside the class. Now we created a class, made objects, added values, and ran their behavior. And it's clean, reusable, and scalable. One class, two students, no repetition. That's a hope changed the game. And this is just a beginning. Pause the video and read out what I gave in explanation for each keyword. Well, we'll deep dive into these concepts in upcoming episodes. Object-oriented programming and procedural programming. Let's compare. Same goal, different mindset. Structure. Procedure style is just a plain code, top to bottom. OOP gives structure. You group the data and logic into reusable chunks using classes. Data and behavior. In procedural, data like name and age live separately from the display function. But in OOP, it's all inside one unit, the object. That's why it feels natural. Code reusability. In procedural, you keep repeating code, but in OOP, you write logic once inside a method and reuse it across all objects. Scalability. Procedural code cracks when the size grows. 5 students. Fine, 50 students? Pain. But in OOP, we use loops or arrays for objects. You scale without breaking structure. Naming system. Instead of writing name 1, name 2, name 3, and so on, in OOP, we just say S1, S2, S3, all created from the same class. Real world mapping. You think in objects like students, bank accounts, vehicle, but Procedure doesn't support that kind of thinking. But OOP does. Maintenance. Want to add an email field? In procedural, you update everywhere. But in OOP, update the class once and every object gets it. Bug chances. When you keep duplicating variables and functions, bugs naturally sneak in. But OOP centralized logic, less confusion, fewer mistakes. Flexibility. In OOP, we can add new features easily. Inheritance, abstractions, we learn this soon. But Procedural doesn't allow the flexibility. In interviews, OOP shows you think like a real developer. Procedural shows you know logic, but not structure. So yeah, same output, totally different mindset. Procedural code works, but object-oriented code wins. Now you know the why OOP is better than procedural. In the next video, we'll build your OOP foundation, starting with class and object. We'll write a code, show memory visuals, and make it fun to learn. If this made things clear, hit that like. If something confused you, comment below. I read everything. Code clean, think big, and I'll see you in the next one. Signing off, Chad.